Hello, my dear children. Welcome to the mathematics class. Today we are going to discuss vector algebra. Vector algebra, the new chapter. In this chapter, we are going to discuss the concepts of exercise 10.1. In the previous class, we have discussed differential equations. I hope you have understood the concepts of the concept differential equations well. I hope you have learnt the sums related to differential equations. Okay, my children, have you not? Right. Now come to this 10.1 exercise concepts. First one, scalar. In physics, you have already learnt. I hope you have already learnt. You know these words. Scalar. A quantity that involves only one value. A quantity that has only one value, that is magnitude, which is a real number. Such quantities are called scalars. Some physical quantities are there. In physics, you have already studied. You have already learned the physical quantities that involves only one value, which is a real number. Okay, my children, that value is a real number. Such quantities are called scalars. Let us take what are the scalar quantities: length, mass, time, distance, speed, area, volume, temperature, work, money, voltage, density, resistance, etc. All these physical quantities are having one and only one value, that is magnitude. They have only magnitude. That is why these physical quantities are called scalars. Okay, my children, understood this point? Right. Come to the vectors. What are vectors? Which physical quantities are called vectors? A quantity which involves magnitude and direction is called a vector. Understood this point, my children? A physical quantity which has magnitude as well as direction, then the physical quantity is called a vector. Let us let us discuss some vector quantities: displacement, velocity, acceleration, force, weight, momentum, electric field intensity, etc. These physical quantities are called vectors because these physical quantities involve magnitude and always and also direction. Okay, my children, understood this point? In this chapter, we will study some the basic concepts about vectors, various operations on vectors, and their algebraic and geometrical properties. Okay, my children, these two types and these two types of properties, when considered together, give a full realization to the concept of vectors and lead to their vital applicability in various areas in physics, engineering. Okay, my children, in all these areas, in the most of the areas, these concepts were used. Okay, my children, understood? Right. Now come to the point number 3, directed line. What is meant by a directed line? Let L be any straight line in a plane or three-dimensional space. This line can be given two directions by means of arrowheads. Okay, my children. A line with one of these directions prescribed is called a directed line. See these three figures, my children. This is a line L, and this is another line L, and this is also L. If you observe the first figure, it has this direction, this upward direction. This line L has downside direction. Okay, my children. And the third one is also upwards direction. So direction is shown by a arrowhead by means of arrowheads. Okay, my children, observe, understood this point. What is meant by a directed line? It has only one direction, either this side or either this side. Observe the figures 1 and 2. They have two directions. This line has a this side above direction. This line has a downwards direction. If we restrict to the line segment AB, then a magnitude is prescribed on the line L with one of the two directions, so that we obtain a directed line segment. So observe this third figure, my children. Here we restricted these 2 points. We have taken 2 points on this line AB. If we restrict this line to this part of the line only, then the part of this line is called a directed line segment. Do you know this point, my children? This is line segment AB. So direction is also given. So this is called a directed line segment. See the figure 3. Thus a directed line segment has magnitude as well as direction. You know length of the line segment. You can measure the length of the line segment. And moreover here direction is also given from A to B. Yes or no, my children? Direction is given from A to B. So this geometrical figure has magnitude as well as direction. So a directed line segment is a vector. So this is called a vector. Understood this point, my children? Here we study a directed line segment as a vector. Okay, my children, keep this point in your mind. Okay, my children? Right. See the figure 3, my children. Observe the figure 3. It is called a vector. Okay, my children, it is a geometrical representation of a vector. It is denoted by AB bar or simply A bar, and read as vector AB bar or vector A bar. Understood this point, my children? How to read a vector? Right. The point A from where the vector AB bar starts is called its initial point, and the point B where it ends is called its terminal point. So for this vector, just by observing this notation, we can identify what is the initial point of the vector and terminal point of the vector. What is the initial point of this vector? A. And what is the terminal point of the vector? B. Understood this point, my children? Right. The distance between the initial and terminal point of a vector is called the magnitude or length of the vector, denoted as modulus of AB bar or modulus of A bar or small letter a. Understood this point, my children? How to denote the magnitude or length of a vector? Right. What is meant by magnitude of a vector or length of a vector? The distance between initial point and terminal point of vector. Okay, my children, understood this point? Right. The arrow indicates the direction of the vector. By observing the geometrical figure, the arrow, or here also by observing this arrow, we can identify the direction from which point to which point it is moving. Okay, my children, understood this point? Right. Note, please remember this point, my children. Since the length is never negative, the notation modulus of A bar less than 0 has no meaning. You know, length of any physical quantity, the length of any physical quantity never be a negative number. So modulus of A bar denotes magnitude of a vector. Length of a vector less than 0 has no meaning. Understood this point, my children? Right. Now come to the fourth point, position vector. Here we are going to discuss about position vector. Now let us recall the three-dimensional right-handed rectangular coordinate system. You have already learnt three-dimensional geometry in your earlier class. Haven't you, my dear children? Right. Now let us recall that previous knowledge here. Consider a point P in space having coordinates ordered triplet x comma y comma z. Okay, my dear children, how do you read this notation? Ordered triplet, ordered triad. Okay, my dear children, do you remember this point? Yes, not ordered pair. Here three numbers are there. That is why it is called ordered triplet or ordered triad. So ordered triplet x comma y comma z with respect to the origin O 0 comma 0 comma 0, ordered triplet 0 comma 0 comma 0. Okay, my dear children, do you remember these points? Yes. Then let us consider this is OX, OY, OZ, a three-dimensional space. Okay, my dear children, P is a point in this space. If you join these 2 points O and P and give a direction from O to P, then this is a directed line segment. Yes or no, my children? Yes or no, my children? This is a directed line segment. So it is a vector. This geometrical figure denotes a vector. So it is denoted by OP bar because its initial point is O and terminal point is P. So it is denoted by OP bar or sometimes R bar. Okay, my children, remember these points. Okay, my children. So the vector OP bar having O and P as initial and terminal points respectively is called the position vector of the point P with respect to O. Understood this point, my children? What is meant by position vector of a point P with respect to O? Right. Using the distance formula, you have already learned distance formula. The magnitude of vector OP bar or R bar is given by modulus of OP bar is equal to modulus of R bar is equal to square root of x square plus y square plus z square. This is the magnitude of vector OP bar. Okay, my children, or the length of the vector OP bar. Understood this point, my children? Remember this point, my children, as a formula. In practice, the position vectors of the points A, B, C, etc. with respect to the origin O are denoted by A bar, comma B bar, comma C bar, etc. Understood this point, my children? Terminal point is O, then it is denoted by A bar. If terminal point is B, initial point is O for all these vectors. Initial point is O. Terminal point is A. Then it is denoted by A bar. OA bar or A bar. Okay, my children. Similarly, OB bar is denoted by B bar. OC bar is denoted by C bar, etc. Understood this point, my children? Is this point clear? Right. Now come to this point, my children. Direction cosines. Okay, my children. Consider the position vector OP bar or R bar of a point P ordered triplet x comma y comma z as shown in the adjacent figure. Observe this figure, my children. This is OX, OY and OZ. Three axes, coordinate axes in the three-dimensional geometry. Here P is a point in the space with coordinates order triplet x comma y comma z. If you join these 2 points, origin and this point, with the direction O to P, then we get a position vector of the point P. It is denoted by R bar. We have discussed all these points in the previous point. Yes or no, my children? Now, if this OP vector or R bar makes an angle alpha, angle beta with y-axis and angle gamma with z-axis. Okay, my children. The angles alpha, beta, gamma made by the vector R bar with the positive directions of x, y and z axis respectively are called its direction angles. These angles made by this vector with positive x-axis and positive y-axis and positive z-axis in the positive direction. These three angles are said to be direction angles. Understood this point, my children? What is meant by direction angles? Right. The cosine values of these angles, that is cos alpha, comma cos beta, and cos gamma, are called direction cosines of the vector or bar. Understood this point, my children? What is meant by direction cosines of a vector or bar? Yes, the cosine values. In trigonometry, you have learned sine, cos, tan. Okay, my children. So, for these three angles, alpha, beta, gamma, for these three angles, if you take cosine, means cos alpha, cos beta, and cos gamma. These three numbers are called direction cosines of the vector or bar. Okay, my children. And usually denoted by letters small letter L, small letter M, and small letter N respectively. Okay, my children, understood this point. Therefore, cos alpha, that is equal to L, is equal to x by R, and cos beta, that is equal to M, that is equal to y by R, and cos gamma, that is equal to N, that is equal to z by R. Okay, my children, understood these points? Right. From this equation, you get x is equal to LR. Yes or no, my children? From this equation, y is equal to MR. From this equation, we get z is equal to NR. Yes or no, my children? So, x is equal to LR, y is equal to MR, and z is equal to NR. So, x, y, and z are nothing but the coordinates of this point P. Yes or no, my children? So, the coordinates of the point P may also be expressed as ordered triplet LR, MR, NR. Understood this point, my children? Right. The numbers LR, MR, NR proportional to the direction cosines are called as direction ratios of the vector or bar and denoted as small letters a, comma b, and c respectively. Okay, my children. Direction cosines and direction ratios. Understood the difference between direction cosines and direction ratios, my children? Direction ratios means there are infinitely many numbers which are proportional to direction cosines, but direction cosines are unique, only one ordered triplet. Okay, my children? Right. Note, observe this point, my children. One may note that L square plus M square plus N square is equal to 1, but A square plus B square plus C square is not equal to 1 in general. Okay, my children, this is the relation between the direction cosines of a vector. Direction cosines of a vector. M square, L square plus M square plus N square is equal to 1. But A square plus B square plus C square, where A, B, C are direction ratios of the vector. Okay, my children, remember this point. Right. Now come to the next point, sixth point, types of vectors. There are different types of vectors we are discussing here. Six types of vectors we are going to discuss here. Six types of vectors. The first one, zero vector or null vector. I think you have already discussed, we have learnt in physics. Okay, my children, let us recall that previous knowledge. A vector whose initial and terminal points coincide is called a zero or null vector. Okay, my children, and denoted as zero bar. Okay, my children, zero bar. Okay, my children, zero bar denotes a zero vector or a null vector. Understood this point, my children? Understood this notation? How to denote a zero vector? Right. Zero vector cannot be assigned a definite direction as it has zero magnitude. Okay, my children, understood this point? Or alternatively, otherwise, it may be regarded as having any direction. We can take this point as this point. Either it has no direction or it has any direction. Okay, my children. The vectors A bar, comma B bar represent zero vector. Understood this point, my children? What is the initial point of this vector? A. Terminal point of this vector is A. So initial point and terminal point. they are coinciding. That is why this vector is an example for a zero vector. Similarly, observe this notation, my dear children. What is the initial point? B. What is the terminal point of this vector? B. So initial point and terminal point are coinciding. That is why this vector denotes a zero vector. Understood this point, my children? Right. Now come to the next type of vector, my children. That is a unit vector. Okay, my children. A vector whose magnitude is unity. That is 1 unit. If the length of the vector is 1 unit, if the magnitude of a vector is 1 unit, then the vector is called a unit vector. Okay, my children, understood this point. The unit vector in the direction of a given vector a bar is denoted by a cap. This is the notation of a unit vector in the direction of the given vector a bar. Okay, my children, this is a notation and it is read as a cap. Okay, my children, remember these notations and definitions, my children. Right. Now come to the next point, next type of vectors. Co-initial vectors. Two or more vectors having the same initial point are called co-initial vectors. In the name itself, it is given clearly. Co-initial vectors means two or more vectors are having the same initial point. Then the vectors are said to be co-initial vectors. Okay, my children, understood this point? Right. Now come to the next type of vectors. Collinear or parallel vectors. Now we are going to discuss collinear or parallel vectors. Two or more vectors are said to be collinear if they are parallel to the same line, irrespective of their magnitude and direction. Understood this point, my children? What is meant by collinear vectors or parallel vectors? If two or more vectors are parallel to the same line, then the vectors are said to be collinear vectors or parallel vectors. Okay, my children? Right. Now come to the next type of vectors, equal vectors. Two vectors A bar and B bar are said to be equal if they have the same magnitude and direction regardless of the positions of their initial points and written as A bar is equal to P bar. Understood this definition of equal vectors, my dear children? Two vectors A bar and B bar are said to be equal if their magnitude and direction should be same. Then the vectors are said to be equal vectors and it is denoted by A bar is equal to B bar. Remember this notation also, my children, to denote equal vectors. Okay, my children? Right. Now come to the next type of vector, my children, negative of a vector. A vector whose magnitude is the same as that of a given vector. Say AB bar. Let us assume that the given vector is AB bar. But direction is opposite to that of it is called negative of the given vector. Okay, my children. For example, vector BA bar is negative of the vector AB bar and written as BA bar is equal to minus AB bar. Okay, my children, understood this point? Negative of a vector. Negative of a vector of a given vector means the direction is opposite but magnitude is same. Okay, my children, remember this point. Remark: the vectors defined above are such that any of them may be subject to its parallel displacement without changing its magnitude and direction. Here we can take any vectors in any direction without changing their direction and magnitude. We can displacement, we can change their positions. Parallel displacement. Such vectors are called free vectors. Understood this point, mentioned what is meant by free vectors. Throughout this chapter, we will be dealing with free vectors only. In this chapter, we discuss the problems related to only free vectors. Understood this point, my children? Right. The concepts of exercise 10.1 were finished. Okay, my children? Right. Now let us just start the sums in the exercise 10.1. Page number 428 in the textbook. Okay, my children? Come to the first question. Question number 1. Represent graphically a displacement of 40 kilometers 30 degrees east of north. Understood this point, my children? Understood this question? We have to represent graphically a displacement of 40 kilometers 30 degrees east of north. Okay, my children? So let us draw the directions. This is east, this is west, this is north, and this is south. What is given? 40 kilometers 30 degrees east of north. Okay, my children, let us take length of 4 centimeters. Here we let us take 1 centimeter is equal to 10 kilometers. Okay, my children, on this graph. Here 1 centimeter represents 10 kilometers. Okay, my children, 30 degrees east of north. So from this ON, you have to move 30 degrees. Okay, my children. So like this. This length is 40 kilometers. Okay, my children. So this is a displacement. 30 degrees east of north. From north side, we have to measure the angle 30 degrees. Understood this point, my children? Right. Draw a line segment. Draw. Let us write the description of this diagram. Okay, my children. Draw a line segment. Draw a line segment. Draw a line segment of length. Draw a line segment of length 4 centimeters on the right of ON, on the right side of ON, making an angle of 30 degrees with ON. Where the scale, here the scale is 1 centimeters. 1 centimeter is equal to 10 kilometers. Thus, the vector OP bar this vector OP bar represents displacement of 40 kilometers 30 degrees east of north. Okay, my children, understood this question and understood this solution, my children? Understood this diagram? Okay, my children, understood here? OP length is 40 kilometers. We have taken the right side because east of north. So for this north, we have to move east side. So 30 degrees angle here we have taken. Then this position of this point P is representing the displacement of that object of 40 kilometers 30 degrees east of north. Okay, my children? Right. Now come to the question number 2. Question number 2. Second question. Classify the following measures as scalars and vectors. Okay, my children, here some measurements are given. by observing the measurements, we had to classify them. We had to categorize as scalars and vectors. See that first one here, 10 kgs. Here kgs. What is the units denote these kgs to be used here? Yes, mass. Yes or no, my children? So mass, to measure the mass of an object, we use these units, kgs. Yes or no, my children? So it is a scalar, mass. Yes or no, my children? Right. See here, 2 meters northwest. 2 meters northwest. Previously we have represented that vector. So it is a vector. Magnitude and direction also given. Okay, my children. So this is a displacement. Displacement means vector. So this one represents a vector. This measurement represents a vector. Okay, my children. Right. This one 40 degrees. Which units are used to denote degrees? Yes, temperature. Yes or no, my children? Temperature. It is a scalar. Yes or no, my children? Temperature. Temperature is measured in degrees. Yes or no, my children? Right. So it is also a scalar. Temperature, the physical quantity, represents a scalar. Next, 40 degrees watts. So it is the units to represent voltage. Voltage, 40 watts bulb, we say like that. So it is also a scalar. Yes or no, my children? Scalar. Understood this point, my children? Right. Next, fifth one. 10 to the power of minus 19 coulomb. What is this unit? What is this measurement? Is denoted. Yes, resistance. Yes or no, my children? Resistance. So it is also a scalar. We have studied all these words: mass, displacement, temperature, voltage, resistance in physics. Yes or no, my children? Right. Now, next question. 20 meters per second square. 20 meters per second square. It is the units. This unit denote velocity, acceleration. Acceleration. Yes or no, my children? So it is a vector. Understood this point, my children? We have classified all these measurements with the help of these units. Okay, my children? For watts, coulombs, meter per second square, kgs, meter, northwest, like this. With the help of these words, we classified these measurements as scalars and vectors. Understood, my dear children? Right. Now come to the third question, my children. Third question. Question number 3. Classify the following as scalar and vector quantities. Here some physical quantities were given. We have to classify them as a vector or scalar. Okay, my children. See the first point, first physical quantity, time. Time period. Is it scalar or vector, my children? Scalar. At the beginning of this chapter, we have discussed which physical quantities are vectors and which physical quantities are scalars. Yes or no, my children? Right. Distance. This is also a scalar. This physical quantity also represent a scalar. Next, force. It is a vector. This physical quantity is a vector. Velocity. This is also a vector. Yes or no, my children? We have discussed all these physical quantities at the beginning of this chapter. Do you remember these physical quantities, my children? Right. Workforce, work. This is a scalar. Force is a vector, whereas workforce is a scalar. Okay, my children. Understood? Right. Now come to the question number 4. Next question, fourth question, my dear children. In the given figure, a square. Here, observe this figure, my dear children. It is a square. Identify the following vectors. Here we have to identify these vectors: co-initial vectors, equal vectors, collinear but not equal. See here, this square, my dear children. This is a vector in this direction, and this vector b bar in this direction, c bar in this direction, left side, and d bar direction is downside. Okay, my children, all the vectors are having the same magnitude because it is a square. So magnitude of a bar, b bar, c bar and d bar are equal. Okay, my children, understood this point. Now come to the co-initial vectors. Which vectors are having the same initial point? Observe this diagram, my children. A bar and d bar. Yes or no, my children? A bar and d bar. A bar and d bar are co-initial because these two vectors are having the same initial point. From this point, this vector is directed like this, and this vector is directed like this. Understood this point, my children? Right. Now come to the second part, equal vectors. What is meant by equal vectors? Which vectors are said to be equal? Their magnitude should be equal and the direction also should be same. See here, b bar is a downside and d bar is also direction downside. Their magnitude also same. Previously I told you the magnitudes of all these four vectors are equal. Yes or no, my children? So b bar is equal to d bar. These two vectors are equal. Understood this point, my children? Right. Now come to the third point, collinear but not equal. Recall that definition of collinear vectors. Okay, my children, what is collinear and but not equal? Collinear means the vectors which are parallel to the same line. Okay, my children, but not equal means direction will be different, opposite. So here a bar and c bar, see the direction of c bar left side, a bar is moving towards the right side. Yes or no, my children? So here a bar and c bar, a bar and c bar are collinear. They are parallel vectors, collinear, but not equal. But not equal because their directions are opposite. Yes or no, my children? Understood this point? Right. In this exercise, one more question is there. Fifth question, that is true or false statements. Please try the question number 5 yourself. If you have any doubts, ask your doubts and get your doubts clarified. Okay, my children? Right.